The new scheme for nudging a molecular gas down to its lowest energy state, called quantum degeneracy, while suppressing chemical reactions that break up molecules, finally makes it possible to explore exotic quantum states in which all the molecules interact with one another. The research is described in the December 10 issue of Nature. JILA is a joint institute of the National Institute of Standards. Molecules are always celebrated for their long-range interactions, which can give rise to exotic quantum physics and novel control in quantum information science, NIST. JILA Fellow Jun Ye said. Our work showed for the first time that we can turn on an electric field to manipulate molecular interactions, get them to cool down further, and start to explore collective physics where all molecules are coupled to each other. The new work follows up on yes-men. Researchers have long sought to control ultracold molecules in the same way they can control atoms. Molecules offer additional means of control, including the differences between these positive and negative charges, called electric dipole moments, cause the molecules to behave like tiny compass magnets sensitive to certain forces, in this case electric fields. When the gas is cooled to near absolute zero, the molecules stop behaving like particles and instead behave like waves that overlap. But they can interact at long range through their overlapping waves, electric dipole moments and other features. This time the researchers first loaded the mixture of gaseous atoms into a vertical stack of thin, pancake-shaped traps formed from laser light, called an optical lattice, tightly confining. Researchers then used magnetic fields and lasers to bond pairs of atoms together into molecules. Leftover atoms were heated and removed by tuning a laser to excite motion unique to each type of atom. Then, with the molecular cloud positioned at the center of a new 6-electrode assembly formed by 2 glass plates and 4 tungsten rods, researchers generated a tunable electric field. The electric field set off repulsive interactions among the molecules that stabilized the gas, reducing inelastic, bad collisions in which the molecules undergo a chemical reaction and escape from the trap. The cooling process removed the hottest molecules from the lattice trap and allowed the remaining molecules to adjust to a lower temperature through the elastic collisions. Slowly turning on a horizontal electric field over hundreds of milliseconds reduced the trap strength in one direction, long enough for hot molecules to escape and the remaining molecules to cool down. At the end of this process, the molecules returned to their most stable state but now in a denser gas. The new JILA method can be applied to make ultracold gases out of other types of ultracold molecular gases may have many practical uses, including new methods for quantum computing using polar molecules as quantum bits, simulations and improved understanding of quantum phenomena such as colossal magnetoresistance, for improved data storage and processing, and superconductivity. Funding was provided by NIST, the Defense Advanced Research Projects Agency, the Army Research Office. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.